Hello, welcome back to Learn Physics. In today's topic, we are continuing with the solved examples of electrostatics chapter. Okay, so in last video I gave you a homework question. So that was 3-point charges plus Q each are kept at the vertices of an equilateral triangle of side L. Determine the magnitude and sign of charge to be kept at the centroid so that charges at the vertices remain in equilibrium. So, 3 charges are there, each of charge plus Q are kept at the vertices of an equilateral triangle. We should find out the charge to be kept at the centroid so that all other charges will be in equilibrium position. Okay, so this one you would have done that. Then also I'll do it here, whether it is correct or not you can check. Okay, so this is an equilateral triangle. Here A, this is B and this is C. Each one charge plus Q plus Q plus Q. A charge is kept at the centroid. How much charge should keep at the centroid to keep these charges in equilibrium? Okay, so I am considering here this is the centroid. So here all other charges are waiting at this point. Okay, so last class I told you it is how to find out this ratio 1:2 in that ratio I told. So L by root 3, the distance we already understood. This distance will be, if L is the length of for each side, then this will be L by root 3, this distance. Okay, so that also we know. So how much charge will be placed over there? We should find out that one. Okay, so for that I am considering at this point which are the forces due to A, force due to B. Force due to A, how much it will be? It will positive charge outward direction. Here positive charge, this also outward direction. So this is FA, this is FB. What will be the force? 1 by 4 pi epsilon 0 Q divided by L square. Here this is FB is same way 1 by 4 pi epsilon 0 Q divided by L square. Okay. Sorry, Q1, Q2. So it will be Q. So it is 1 by 4 pi epsilon 0 Q square divided by L square, and here 1 by 4 pi epsilon 0 Q square divided by L square. Okay, so how we can find out? So all these should be in equilibrium. For that, how much charge will be kept over there? Okay, then for that, what will be the effective force which is acting on this side? See, we can draw the parallelogram, and this will be F1. I am considering it as F1. How we can find out the value of F1? F1 equals root of FA square plus FB square plus 2FA FB cos of angle between A and B. What is the angle between A and B? What is this angle between here? This is 60 degree, right? So this will be 60 cos 60. Root of FA square. FA is same. Magnitude of FA and FB are same, right? So here we can write it as 2FA square 2FA square into 1 by 2. So how much you will get? You will be getting it as cos 60 is 1 by 2. So here we will get it as root 3 FA. Okay, so this will be the force acting on F1. This will balance at the point D. Let Q be the charge at D. Okay, so force acting at D will be equal to, how we can find out? 1 by 4 pi epsilon 0 small q into, if Q is the charge over here, divided by, what is this distance? L by root 3. Isn't it? L by root 3 the whole square. Okay, so here we will get it as 3 by 4 pi epsilon 0 Q square divided by L square. So FD and F1 should balance, then only it will be in equilibrium. For that F1 is equal to FD. So while we are equating that one, F1 is root 3 into 1 by 4 pi epsilon 0 Q square by L square. That is equal to 3 by 4 pi epsilon 0 capital Q square by L square. Not capital Q square, capital Q into small q by L square. So 1Q and 1Q will get cancelled. See, root 3 and 3 will get cancelled. 1 by 4 pi epsilon 0, 4 pi epsilon 0 will get cancelled. L square and L square will get cancelled. So from here we will get it as small q equals root 3 capital Q. That is q equals q by root 3. Here, understood how we are finding? So your final answer, you will get it as q by root 3. What you should do? See here, F1 value you should find out and find out the value of and if it is in equilibrium, this effective force should balance with this force. Okay, so that force also we found out, like it is q by root 3. Okay, you got the correct answer. I guess it is correct only. So, and if anyone has a doubt in finding out this distance L by root 3, you can watch the previous video. I'll give that link in the description box. Okay, so you can watch that and find out how we are finding out the value of L by root 3. That is nothing, that is mathematics only, how to find out the centroid and the distance from here to here, how much it is. It's 2:1 ratio, so 2 by root 3, from there we are getting the value. Okay, so clear, understood? So today, next we are going to study about the dipole. In that solved examples we are going to do. Okay, so next is question from page number 29. Okay, two charges plus or minus 10 microcoulomb are placed 5 millimeter apart. Determine the electric field at first one, a point P on the axis of the dipole 15 centimeter away from its center O on the side of the positive charge as shown in figure. Figure is also given. Okay. Second one, a point Q 15 centimeter away from O on a line passing through O and normal to the axis of the dipole. Okay, so axis of the dipole and the next one, what is that? The axis and equatorial plane. Both the things we should find out. Okay, so the electric field due to a dipole, that is in the axial line and equatorial line we know. Okay, so how we can find out the electric field due to the axial line? E is equal to 1 by 4 pi epsilon 0 2p by r cube. That is the formula to find out the this one. What is that? Distance from the electric field due to electric field 1 by 4 pi epsilon 0 2p by r cube. This is in the axial line. Okay, equatorial line means E is equal to 1 by 4 pi epsilon 0 p by r cube. This is for equatorial line. Okay, so this is for equatorial line and that is for axial line. In equatorial we will get this negative sign. So here the two diagram is given. So for the first one, see this is A and this is B, minus 10 coulomb, 10 microcoulomb, and this is plus 10 microcoulomb. Okay, center is O and here it's a point P. From O it is 15 centimeter. So I'll read the question now once more so you will get an idea. Two charges plus or minus 10 microcoulomb are placed 5 millimeter apart. So this is at a distance of 5 millimeter. Okay, then is apart and determine the electric field at a point on P on the axis of the dipole 15 centimeter from the center of the dipole. So what is this distance? This is R. What is this distance? A. Okay, so how we are coming to this conclusion? because R is very much greater than A. Comparing A, because actually here it is R square minus A square the whole power 1 by 2, like that you will be getting, right? So from there we are considering R is very much greater than A, so we are coming to this conclusion. Here whether R is very much greater than A, yes, this is 15 centimeter, here it is 5 millimeter only, right? So it is very much greater than A, so we can use this equation, okay, for the axial line. So we can find out the axial line electric field as E is equal to 1 by 4 pi epsilon 0 to P. P means Q into A. Q, one of the charge into distance between 5 into 10 to the power minus 3 divided by R cube is 15 into 10 to the power minus 2 the whole square. Okay, so 9 into 10 to the power 9 into, here it is 10 into 10, 100, 10 to the power minus 1 will exist. So 225 into 10 to the power minus 4. Okay, so here 9 by 225. While solving you will get it as 2.67 into 10 to the power 5 Newton per Coulomb. So in which direction it will be acting? Along BP, outward direction, right? So it is acting along BP. Okay, now we should, the second part of the question is a point Q 15 centimeter away from the line from O, on a line passing through O and normal to the axis of the dipole. For the second one, the diagram is given like this is minus 10 microcoulomb, which is at A, and this is B, which is plus 10 microcoulomb, and which is at a distance of distance and all same only 5 millimeter, and a point O is given over there, which is taken from the center here, that is at a distance of 15 centimeter. So here in which direction it will be acting? We know that as per diagram we already did that, and if it is minus 10 and plus 10, E will be acting in this direction. Okay, so here what is the formula? E is equal to E due to equatorial plane. What is the difference? Half of axial line, half of electric field due to axial line. So here we will get it as 2.67 into 10 to the power 5 divided by 2 Newton per Coulomb. So this it will be acting from the direction P to A. In that direction only it will be acting. So clear? So this is how we will be finding out the answer for that one. And in your textbook, while you are going through so many calculations are given. So this much is enough actually. This is as per this diagram and as per the given data. It's a very simple calculation only. If you are using this instead of this one, if you are using the same thing, because it is, you would have done that in our in your derivation. The same derivation, if you understood properly, you can do that very easily because everything is given. Okay, it's a direct question. Okay, seeing the steps in your textbook, don't get panic. It's very easy. What are the, if you know the concept, it is easy to solve the equation. Okay, clear? Next is from the question related with the Gauss law. Gauss law is electric flux linked with the closed circuit as closed surfaces equal to 1 by epsilon 0 times the charge enclosed in the surface. Electric flux through a closed surface is electric flux through a closed surfaces, that is closed integral E dot ds is equal to 1 by epsilon 0 times charge enclosed in the surface. Okay, so this is Gauss law. Okay, phi is equal to E dot ds. That also, using that one, electric flux, that one, that is the first question. The first question is related with the flux, electric flux. So here I'll read the question. The electric field components in figure in diagram is given are Ex equals alpha x to the power half. Ex equals alpha x to the power half. Ey equals 0, and Ez equals 0, in which alpha equals 800 Newton per Coulomb meter to the power half. Calculate the flux through the cube. So first we should find out the flux through the cube. And second one, charge within the cube. Next we should find out the charge within the cube. So that assume that A equals 0.1 meter. Now I will draw the diagram. Diagram is given like one cube. This is the cube which is given like this, and here this is X and this is Y and this is Z. Okay, here it is A, this side it is A, each side is A. Okay, it's given A equals 0.1 meter, it is given, and this is perpendicular acting along left side, this is the perpendicular acting along right side. So here this is the question which is given. So we should find out the flux through the cube. So how we can find out the flux acting through the surface? Flux will be equal to E dot ds. Right. A dot B. AB cos theta. So E ds cos theta. Here we know electric field is acting only along the x-axis. Okay, so electric field is acting along the x-axis. For all the directions of theta, if theta is 0 or theta equals 180 degree, then only this flux will be existing. If theta equals 90, flux will be equal to 0, cos 90 is 0, right? So along x-axis, electric field should act along the x-axis, it is acting only through the x-axis. So in x-axis, parallel to x-axis, area vector in which and all direction it is acting only through the right side and through the left side. See, the all other sides are perpendicular to that. So if I am considering this one, it is perpendicular to the surface as perpendicular to the electric field x-axis. Okay, if I am considering the other side, that side also will be perpendicular to z-axis. So all other perpendicular along y-axis and z-axis, all are perpendicular. Through that surface, if flux will be coming out? No, because the angle between electric field and the surface are at 90 degree. Okay, so that one we can't consider. So here this rest only through 0 or 180. So that one, which and all sides it will be coming? This right side, that is this side, and the same way this side. Okay, these two sides alone will be acting for this flux. So how we can find out the flux here? Flux equals E equals Ex ds cos 0 if it is through the right side. Flux through left side will be equal to Ex ds cos 180. So here cos 180 minus 1 minus Ex ds. Now here you see, so total flux will be phi r into plus phi l. Okay, now we are going to substitute the values. Ex is, what is Ex? Alpha x to the power half, and ds, what is ds? A square ds. What is surface area at this side? A square. A square cos 0 is 1. So alpha into, what is x distance here? This distance is a. From here to here, what is that distance? Again a. So together it will be 2a. 2a the whole power half into a square. Here what will be? Minus e, yes, e instead of e, alpha x to the power half. So to the left side, what is this distance? A. Alpha a to the power half a square. Okay, so while we are substituting it over here, we will get it as alpha 2 to the power half a to the power half a square minus alpha a to the power half a square. So in that alpha we can take it outside. A to the power 2 plus 1 by 2 means we can take it as 5 by 2. A to the power 5 by 2 we can take it outside, and 2 to the power half minus 1. Here alpha value is given as 800 and A is given as 0.1. So 0.1 to the power 5 by 2 into root 2 minus 1. So this one, while you are calculating, you will get the value of 5. Okay, so flux, we got the flux value. Now our aim is to find out the charge. The second question was to find out the charge. I'll do it over here. Charge Q equals, what is the formula how we can find out? Using Gauss law. Gauss law is charge enclosed in a surface is equal to 5 by 1 by epsilon 0. Flux linked with the circuit is equal to 1 by epsilon 0 times the charge enclosed in it. So Q equals epsilon 0 into 5. Epsilon 0 into 5. What is the value of epsilon 0? 8.854 into 10 to the power minus 12 into 5 value. This one, this calculated value, you should substitute over here. You will get the value of charge in Coulomb. Okay, understood? So this kind of questions usually they will ask. Okay, so please be comfortable with this kind of question, and same kind one question I will give you as a homework. Okay, the question is the electric field components due to a charge inside the cube of side 0.1 meter are Ex equals alpha x. The value of alpha is given. Here we wrote it as alpha x to the power half. Same way here it is alpha x, and Ez equals 0. Calculate the flux through the cube and the charge inside the cube. The same way you can do it, and try to solve the next solved example also. Same way only you should do. Okay, try to solve it, both of it. If you are not getting, you please inform, and I will be giving the answer also in that along with that question. Okay, just answer I will give. If you are not getting it, you tell me through the comment box. I will be doing it in the next video. Okay, so all of you are preparing nicely for your exams, right? Okay, then do well, prepare the timetable and go through all the questions properly, and okay, do well, okay, without wasting time. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.